complete that statement. Encoder, decoder. What happens exactly with an encoder? You have n and 2 power n combinations, right? You have n and 2 power of n combinations. Look-wise, they are reverse in nature. Is that correct? Looks-wise. That means inputs, outputs. Outputs, inputs. They are inverse in nature. That means they are repetitions. Who are outputs here are acting as inputs here. Who are inputs here are acting as outputs. But the meaning of the inverse nature is a little bit different. Okay, that's what I wanted to reveal from that yesterday's truth table. If you see there, you have, how many of you have yesterday noted down the truth table I have given for the encoder? All have taken?
Yes, ma'am.
Almost. Okay. So now there I gave an option. You have Y0 to Y7, which is giving some outputs ABC. Right? And now in that I have followed a format where at every point only one input is active and the others are either don't cares or zeros. Is that correct? Only one of the input is active. Like see, for example, if I have like this, so all goes on like that. So I have a definite combinations of that. That means more only which is active. That one only is considered. That means only one combination of the output will be there. And now, for example, if it's like this, okay, so only one combination. That means you go row wise. You go row wise. In material of how many are active, the highest one is preferred. Right? This don't care doesn't matter. Please try to understand. We have for every row a particular combination of the output. And moreover, I gave a separate variable called D or P, which is showing that what? That means it is an indication that one of that active member is high. One of that is active is high. It is just an indication, which we will always call it as priority. Is that correct? Why nobody is responding? What happened to you?
Yes, sir.
Yes? Right. So now, hello? Am I in the meeting or out of the meeting? I am there.
Yes, ma'am, right there.
Okay. So now, question comes. See, for any row combination, you will have a specific output entitled only for that. Is that correct or not?
Yes, ma'am.
Correct. So now, don't worry about this. This is just for our information that one of that is active. This is for our information, and moreover, some of the ICs do have this device which blinks to tell that one is active. Right. So you have to understand encoder is a multiple input combination which gives an output specific or specified for the one who are supposed to be active. That's what it is. That way it is inverse with a decoder, not like in another manner. Just like that we will reverse it, we will get a decoder. It's not correct. Okay, so I hope this explanation will do. I will give 5 minutes for your questionnaire. Please have any questions between decoder and encoder, please post it. Right, I'm giving you 5 minutes. Please ask if at all you have. Otherwise, I'll go to the next combinational circuit. Yes. Nobody have any questions? Strange. That means you are stopped thinking or what? Ask something. Okay. Otherwise, I will start a discussion. Can the encoders, like for example, you have decoders. You told that you have 3/8 decoder, right? You have a row of AND gates. Is that correct? Row of AND gates, right? Can I use NAND gates there? What, you people have taken a oath that you will not speak or what? Other classes you are nicely conversing with me. What happened to you? Huh? Nobody is talking. Where is Sankar? Where are those? Like Hassan is there. Why nobody is talking anything? Hiranmay?
Yes, ma'am.
So what happened? Okay, so Hiranmay has posted. So ma'am, parity variable will be 0 or only one combination. Is that what the question is, Hiranmay?
Yes, ma'am.
Yes.
For 0, 0, 0, 0, 0.
So for only one combination. Yes, only to indicate that the input side nothing is available. Okay, so that means you are actually pointing out for the combination like this. That time only the 0. To show that none are active here. Right? This is what an encoder is. Now the same scenario or the same explanation, you can put it for a one who is reverse in nature. That means it will be all ones and only 1 0, and that also can be there. That means it is in not reverse, I should say. It will be in the complement manner. That type of designs are also there. Just like decoders, not only with AND gates, we can create with NAND gates also. Only thing is we will get F complement instead of F. That way you are well versed in your basic electronics, I think. Is that correct?
Yes,
Only
ma'am.
one question. Any more? Any more, please? Shweta?
Yes, ma'am.
Any questions?
No, ma'am.
No questions. Okay. Right. So now let us discuss a new combinational circuit, little bit interesting. ROM, about ROM. So now what do you mean by ROM? ROM. Yes, you can give your inputs. What do you mean by ROM?
Read-only memory.
Yes, excellent, Shweta. Read-only memory is there, but now we are engineers. We need to find out what exactly is a read-only memory. So now I can just say that it's like a briefcase with lot many, what we say, cupboards in that, and each cupboard is having a storage, and that storage is fixed. Please try to understand. Imagine a big cupboard with lot many shelves in that, and each shelf is having bits. This is how a memory looks exactly. This is memory. Okay, and each memory will be having words in that. We will say words. These are the technical terms. This is memory. I think in your school days you might have studied this. Okay, so this is a memory, and I have lot many shelves in that, and each shelf is having words, right? And each word is having specified number of bits, right? So might be it is having some bits. So how many bits are there here? That many bits only here also. Like that, this memory will be. Normally, you will say memory size. Is that correct? So now, can you explain me what do you mean by this? Because memory size you will tell, na? Can you elaborate? Can you elaborate? What do you mean by 512 KB means? What happened? Hey, what's wrong with you? Why nobody is talking to me?
Ma'am,
Yes. Thank you.
ma'am,
512 KB means what?
ma'am, does that mean that each word will be 9 bits long?
No. Don't go into this, please. You explain me what do you mean by this. So that I will go to the design. Now you people will be able to design a ROM for yourself. That's what I wanted to make you. Now can you explain me? Have you seen this one, memory size of 512 KB?
Yes, ma'am.
What does this specify? This is byte, kilo, and 512. So each 1 will be having separate group, means 512 represents what? K represents what? Byte represents the number of bits, so 8 bits. Okay, kilobyte, 8 bits, and kilo means 2 power, kilo means 100. What do you mean by kilo?
10 to the power 3.
10 to the power 3.
Thank you. So 10 power 3 and bytes is 8. 8 bits only, na? 1 byte means?
Yes, ma'am.
Okay, happy, right. So this is 10 power 3. This one is in 8 bits is there, and 512 is what? What do you mean by 512? What is the importance of that? Have you people heard of this? Kilobytes, megabytes.
Yes, ma'am.
So now please explain that. That only I am begging for the last 5 minutes. So I can say what Shweta is telling. Shweta was telling something. What is that?
I was thinking that 512 is 2 to the power 9. So I was trying to think something like that. So
Okay. So now let me elaborate. Okay, it might be fun. Okay. So this is 512 kilowords of 8-bit length. First, I will decode like this way. First thing is 512 kilowords of 8-bit length. That means I had a clarity that this is separate, this is separate. Is that clear? Is this clear? 8-bit length. That means because it is bytes given, so this many words are there, this many words are there, each one is 8-bit length. This is what it means. Okay. Then you come to your 512 means 2 power.
9.
Yes. Kilo means?
2 raised to power 10.
Yes. So these all comes into the size. This becomes into the number of bits. So size of the memory is actually informed with words by bits. Word by length. That is the size. Word by length. So this is word, this is length. Right? That makes a size of the memory. Please try to understand. Okay, so word, number of words, and each word of how many bit length, that is what gives the raw size design. Okay, but now we will go deeper into that. Now how we are going to actually create this? Now is it clear? Is this clear or not?
Ma'am, these words that you said, these words are like stacked upon each other or
Yes.
horizontally?
Now that's what word I didn't break. At present only size I told. Now what is the word I will go and create? Now I will show you how the words are created. Okay?
Okay, ma'am.
Words are created. Words are now created. How you are going to create, I will tell you. But length is same. 8-bit length means same. Okay? Now hold on. I am just telling that how these words are created. They are, yeah.
If we want to write 1 bit length, then how will
1 bit or 1 byte?
1 byte?
Acha, 1 byte length. 1 byte length means it is having 8 bits.
No, ma'am. I mean 1 bit, not byte.
In 1 bit. So 1 bit occupies 1 memory cell. 1 memory cell. Now the word is terminology, something different. Cell. It became a cell. It is not a shelf. Shelf means you will have lot many cells in that. You will have a big shelf. In that cells are there. The cells are called flip-flops. So that becomes the basic ingredient of a memory design. Now we are in a superficial covered case. Afterwards, in the next sequential circuit, you will go to the memory design of each cell. That is a separate design. You are trying to write 1 bit, no? Is that correct? Somebody asked. Yeah.
One shelf is occupies 8 bits.
Yes.
If I want to create a size of 16 bit, So
16
it will be
bit.
not possible in that.
No, it has to go and occupy 2 shelves. Because my size of the word shelf, each word shelf is only 8 bits. If you occupy 16 bit means my word will overflow. So I have to go and occupy another shelf. So 16 bit will be again segregated into 8 plus 8. So 8 lower, 8 higher. That means your 16 bit means here to here. No? Sorry, for the rest of the class, please don't mind. Somebody asked me this question, let me tell you. 0 to 15, those are 16 bits, right? So I will have A less B, 8 bits, higher, lower order. I will say lower order. Lower order and higher order. Okay, so I'll create for myself. Okay, prepare myself. So 0 to 15, I'll keep from 0 to 7, one order. Okay, then 8 to 15, higher order. So this will occupy one shelf. This will occupy another shelf. Is that clear? Whoever have asked.
Yes, ma'am.
Okay, so this is called what? Memory writing actually. Right. So now, if at all if you don't mind, should I go back to the class? I mean, to my regular this. Regular what explanation? What happened to you? I got response. What's happened? Only Shweta response. What happened to the others? Like you people want to be in mute condition all the time. Wait, we are calling you back. Hopefully. We are doing that. Okay, your 5 years will be in by ending of by this month end. We are calling around 250 people back, so you will be back soon. Don't worry. Okay. Chalo. So now, if at all I want to tell you how a ROM looks. A ROM is nothing but, please try to understand. A ROM is nothing but a combination of words and bits. Please try to understand. Okay, so words and bits is the combination of the ROM. But how exactly words are created, I am going to tell you. So now let me take a box. I am just taking an example of 8 words by 4 bits. This is ROM. Okay, now this is just an example I am giving. Okay, now 3 inputs. Right now, this 3 inputs, I will just explain what a word is. This 3 inputs will go and create 8 words. First, concentrate on the words. Now, 3 inputs will go and create 8 words. Now, you should have already got a clue which type of combination circuit has that capability. I might be using the term called words, but if at all you carefully observe, 3 input combination leading to 8 different combination. Who has that capability?
Decoder.
Yes. So that means the word creation. Who is the mastermind behind the word creation? They are what?
Decoders.
They are decoders. That means when you open this box of ROM, definitely the first section is a decoder section. ROM means it's not a single box. Now I am unfolding that boxes. So first blue color underline I am taking into picture. So as an example I am taking. So 3 inputs called ABC has gone and created 8 different words. That means we are having a decoder as a part and parcel of that. Is that correct? Everybody agrees for that?
Yes, ma'am.
Okay. Now comes to the next one. What is that by 4 bits? Is that into 4 bits means, is it actually pointing out to the 4 lines there? Or can I say each word consists of 4 bits in that? Is it talking about the output lines or is it talking about the 4 bits? Both means the same only, no?
4 bits.
Yes. So this 8 words are having 4 bits each. That means when you open this one, you will have a decoder, you will have 3 inputs ABC, and you will have 8 lines. 8 lines, yes or no? 8 lines, no? 8 lines are coming, right? That is called word line, and after that line, we are getting 4 outputs. This is what the makeup. This is decoder, right? Now there will be a mesh. This is called the memory mesh. That design only we are trying to do. Till here you are knowing that. Why? Because it gives 3/8 combination, nothing but your terms, na? After that, what is happening is our new entry. Everybody clear? How these 4 are connected here. So how that is linked to this? That only is the combination. Please try to understand. I am making it very crisp and making you to try to understand. I am making it unfold. So first portion is 8 line. 8 lines, how it can be formed is a very easy combination. Is that correct? 8 lines, how it can be formed? Because we will have 3 inputs and I will have definitely 8 min terms there existing. Is that correct or not?
Yes, ma'am.
Yes,
Right.
ma'am.
So once the 8 lines have come, afterwards the mystery is how these 4 bits are created from that and how this has been formed. Okay. So I'll take up a small example to explain the same problem. Okay. I'll use the same notation, nothing much. Right. But only thing is I will try to use the whole board. Okay. I'm trying to remove this. Again, I will redraw so that I want the whole board. Okay. So now this is a small A, B, C. Okay, same thing I am writing very crisp. And now I have 4 lines. Right. Now, a table is provided to you already. This is given by us because we are the designers, so it is given by the designer. It's like this. So these are the outputs 0, 1, 2, 3. Let me take up that example. So you will have under F0 1, 1. Okay, just a second. I have taken a problem, right? So that it is clearly mentioned here 1, 1. It is given by as a part of the problem. How it came? Like we were wanting to create a memory like this. Okay, so now 0, 0, 1, 1, 1. 1. Okay, then afterwards 1, 2, 3, then all zeros. Okay, so designer wrong for this. This is what the question is. Okay, now let's start a design. Simple. Right? So now for the design, I will take first your 3 inputs A, B, C. Now a decoder will be there, which is nothing but 3/8. Okay, so now I will now draw 8 lines. These are called word lines. First, we should analyze what exactly is happening. From the table, we have to design this mesh. Everybody, please start. Okay, 8 lines are there. Is that correct? So now, it is a circuit we are trying to create. Okay, so now, if you see what is this? What is that? Resistance, right? Is it correct or not? What
Yes, ma'am.
happened to you guys?
Yes, ma'am.
Yes. Hold on. Now, this is very simple. This looks like a digital one. All of a sudden, ma'am has gone to circuit analysis. Circuits have come. There is a ground also. There is a resistance also. What is happening there? Are we trying to create a switching thing here? Yes. The word is yes. Because memory, how it is written, it is exactly switching. Right? We are creating switches there so that a word can be encrypted or word can be written there. That's how the memory cell is. Memory cells are nothing but a full mode. Who are interested or who are in cyborg or something, they might have already studied about memory. Like memory means it is having fully connected one. If you are writing means you are making a interconnection between the lines. That's how the writing portion will be there inside the memory. Writing is what? You have to create there on a mesh. So this is called a mesh, a memory mesh. And what that memory mesh has, it has words. Like you have combinations like this. Okay, so what are these words telling? You have combinations like this. Did I miss something? 0, 1, 2, 3, 4, 5, 6, 7. Is that correct? So these are there, and these lines are called word lines. These are called word lines. Now, what exactly is happening? Now, this one are called F0, F1, F2, F3. You should have checked that. Purposely, I kept only 4 lines because I have only 4 bits to be written. Okay, now, if you carefully see, F0 comprises of what combinations? F0 is nothing but sigma of what all words? I am using a mid-term combination. You have M0, right? You have M1, you have M4, you have M6, right? That much only I will take. So this is M0 only. So now this line, a connection is made to this line. Now please carefully understand. Again, I will redraw there so that there won't be any hatchment. This is this line, this is this line. I am taking a switch from this word to this one. What is that switch? It is like this. Connection. This switch. What is this? It is connecting this to F0. Okay, now who is this? M0 is there. M1 line is also connected. This word line is also connected. Right? Then M4 line is connected. Then who else is there? M6 line is connected. Right? Now these are called semiconductor switches. Okay, so when we read F0, what all comes out? F0 is a combination of, we will see where the switches are connected. Serially we will go. That means we will see column wise. So F0 is a combination of this switch, this switch, this switch, this switch. What about the other lines, word lines? They are not connected. So it is not a part of our F0. Is that clear?
Ma'am, how did you write the values for F0, F1, F2, F3?
That is, yes, that's what I told. This is a provided mesh. I didn't presume it. It is a provided one. This is a information provided to us to write these words like this. You can create another mesh, no problem. This is not, I didn't get some for myself. This is provided to me. This is a data sheet provided to me. I didn't write on my own. F0 values are given to me. Please try to understand. It is a wrong design, wrong truth table is provided to us. They only told you create this input, this many outputs are there, and these are my word lines are there. That much. I didn't presume anything. I mean, I didn't get just out of any what for myself. No formula is there. They have provided to me. Is that the question answered?
Yes, ma'am.
This is provided. This is always provided. Now I'll tell the inner meaning how it will be provided and who will be providing us that. Okay. Now this one, F1. Similarly, F1 also I can make switches. So F1 is what? What is F1? M2, M3, M4, M6,
M7.
Is that correct? Okay. So now, these are the words which will be entitled, which have the right to create F1. That is what from the truth table it tells. So go on adding your switches. M2. Then different notations are there and different symbols are there. Normally I told you this is how we do. So I'm very bad at drawing. We will draw like this. A rectangle with the arrow inside that and then connection. That end and this end. Okay. So M2 is that. Then M3 is there. So please make sure the drawing is correctly done. M3. M3 is what? So I am with M3 is this. Right? Then afterwards, M4. Right? Then M6. Did you observe? I am not taking it to the corner of this one. I am only holding it here. Did you observe that, everybody? M7. Okay? Is that fine?
Yes, ma'am.
So, like that, you keep on doing for F2 as well as F3. Right? So now, yes. Go ahead. What's wrong with you guys? So complete that.
Ma'am, there is no switch at 3.
What happened?
Ma'am, actually you have connected for M1. I think for F1 it should be M2.
Okay, now you can just check out. For the same thing. Did I connect wrong? M not. There is no 3. M3.
No, ma'am, you have connected M1 instead of M2.
Okay, sorry. Yeah, I have shared the screen. Please check out. I have shared the screen. See, from here I viewed that way, so I got wrong. Okay. M1 I have connected. I'm so sorry. M2. Right? Now can you see the screen? Everyone.
Yes, ma'am, visible.
Now visible. Now you can check out also. You please try to analyze them for the same truth table what I am showing on the board and the connections there, and you can see the switches. Everyone, please try to check. So you have switching elements, you have the output lines, and you have the word lines, everything pointed out in that. Is that clear for everyone? See that resistance, why to tell that? Because the switching element can be a diode. Okay, so once the analog devices are used, we need to use a grounding options, we need to use a circuital analysis. Is that correct or not? Everyone, it is clear. It should be clear for everyone. Are you able to see everyone?
Yes, ma'am.
Are you able to understand? Okay. Now let's answer your questions. Like how I will get a truth table like this. Now, prior to that, let me understand your computer knowledge. Okay, you might have understood about ROM. What is ROM? ROM is only read-only memory. That means once the information is put in that, you cannot change. This is what the concept is, right? Is that correct? Now, we are not into digital electronics. We are in a general discussion. I am a layman and you people are actually educating me. Can you just explain read-only memory? In that, how the information is placed? Now it's a free time. You can talk. You can analyze and talk to me. Please. How information is sent? Is that a miracle? Okay. Something like Kulja Sim Sim or something like that. They will tell and information will go and sit there. No, na?
Encryption.
Okay, the word is again technical. Okay. How the memory is created? That's what I'm telling you. What do you mean by creation of a memory? And did you see here? I am telling about switching elements here. Okay, switching elements are devices. Again, I am showing these are switching elements are devices. So, how devices have entered into memory? Okay, don't bother. Don't bother to talk also. So, this is what your designer for ROM. Happy? Any questions in that? In this? If you want to ask, otherwise I'll teach the next one. No problem.
Ma'am, some of the min terms are repeating, like M2 is connected to more than one switches. So
Doesn't
why?
matter. Doesn't matter. See, a word can be created with many things. Like, see, I'll tell you. Just a second. If at all, switch connected means if I give one notation. Okay, alpha. And switch not connected is beta. Okay? Right. Now, if you check here, F naught, switch connected and switch unconnected. What? F naught only you take. What is the one we will get? What is the word we will get? Switch connected and switch interconnected. I'll start. This is alpha. Starting with alpha, right? First one is connected. Then comes another alpha. Then comes beta. Then comes beta. Then comes alpha. Then comes beta. Then comes alpha. Then beta. Is that correct? Is this the F naught thing? If I keep this notation. Switch connected is alpha. Switch not connected means beta for me. Is that correct?
Yes.
Okay. Hold on. Right. It is it confusing? No, no. Connection means I am telling that for myself it is alpha and this is not connection beta. Right. So F naught is having this pattern inside. Okay. F naught is who? F naught is one line of your memory. Right. Now F1 is what? Who is F1? F1 also you tell me in terms of alpha betas.
Beta, beta, alpha.
Yes. If you are smart enough, you can do from here only. Right? Okay. Now F2. F2 is what?
Alpha, alpha, alpha.
Alpha, alpha, alpha. Beta,
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 beta, beta, alpha, beta. Right? F3 is what? Beta,
beta, beta.
alpha, alpha, beta, alpha, alpha, alpha. Okay, now things will not be like this. Now, when the memory is read, it will be read like this at a stretch. Okay, now the first drop will be what you know? The first word of 4 bits will be alpha, beta, alpha, beta. This is your first case. First shelf stores this. What is the meaning of this? Alpha, beta is a pattern. Okay. Now, the next shelf will be what? This one. Okay. So, what is that? You got alpha, beta. Same value might repeat. Who knows? We don't know. That is the second word. Third word is what?
Beta, alpha,
Beta,
alpha.
alpha. That is the third word, like this. So now these are the shelves, and inside that are the bits. And if it is min terms so many times are repeated, yes, it can be repeated, because question comes, they are not bothered about this decoder. It is the repetition of the words repetition of the switches they are taking from the word lines. The word lines are contributing to different shelves. Please try to understand. These are shelves. These are word lines, and these are the output lines. These are exactly the output lines. Okay, these are the switching elements who are creating this one. And alpha beta has a name. Okay, it has a pattern in that. Like maybe it is like 1010. No? It has a decoded meaning inside that. It has a particular task to do inside that. Is that correct? Did you understand? So this whole mesh will be provided to us when a truth table like this is created, is informed to us. So they keep on adding the switches there, and then that particular one, somebody told encrypted. What do you mean by encrypted? Somebody has given again that one. Encrypted means, what do you mean by encrypted? Encrypted means what? You have information and you encrypt that. Isn't it encrypted in bits? Yes or not? The information in bits. What is the real message behind it? Message is something different. We are encrypting using binary. Don't you say encryption word? What else we can say?
Encryption basically is encoding information. That's it.
That is what we are doing. Information means what? Message. Message you are encoding in terms of binary bits. See, 1010 has a message bit. I don't want to go into the communication. I teach communication. Okay, so that goes into information theory and coding, where the encryption comes. But for you, in the memory, if it has a patterns of ones and zeros, they do damn have some real task to tell. Is that correct or not? Real task to do. Without that, ROM is just like that sitting inside a computer. It has a task, no? When the CPU is switched on, your OS has to start. How it will start? Can you people analyze? If at all I ask, all will be silent and staring at the board. Earlier, at least you people used to talk. I don't understand why you're not even communicating also. Right? So when I connect the computer and then switch on the switch, it will start. How the windows are getting started? Without any just the power button I will do, automatically it will start. Don't you think the ROM has to initiate something inside? No answer. All dumbos.
Yes.
Ma'am, can you repeat?
If at all I switch on the CPU, just a power button I will push, my Windows will get started, like computer will get started. How? Power is doing the I'll give the electricity and my Windows will start. Don't you think inside ROM is doing something? Yes, Abhijit, I have repeated.
Yes, ma'am. Yes, ma'am. I understand. The ROM just starts itself when you
It has
on
to
the.
start now. Then where the indication is coming? Just the electricity went, then it will come.
Ma'am,
Don't you
ROM
think?
stores the information to start.
That's
the-
what, how that information is stored. This is how it is stored. This is a permanent mesh created and kept inside the ROM. So that is what the information is. The information is nothing but your patterns, how to start the computer. Don't you understand that one? At least that information you should be having now. The ROM has the information or the ROM knows the procedure how to start a computer when the electricity is provided. Is that correct?
Yes, ma'am.
So how did you make the information enter into the ROM? This is what I'm trying to teach for the past 1 hour. So this is how the creation of the information is. Creation of the information. That what do you mean by VLSI designing? Yeah. Hardcore designing is like this only. We need to have a meshes designing. Again, it goes to the circuital analysis. Again, it goes to the switching elements. Again, we will have to complete. Now, if you see, if any of the grounding goes now, then it will be very big problem. Then the internal problem, hardware problem, they will tell some things will not be rectified. That is what happens. Something will be out. Some of the lines, if burnt is there, gone case. It won't start also. Nobody has ever, saw that such type of problems created in the computer. Hardware problem, they will tell you.
Moisture sometimes.
Yeah, so short circuit happens now. Moisture short circuit will happen. Obviously, it's a board now. So grounding problems can do something. Otherwise, heavy lightning can do some line will get short circuited. These all are problems only. So basically, we are not looking into what are the problems. But my question here is, it should be ROM is nothing but a creation of an electric mesh, memory mesh, we will say. And in fact, why I'm stressing on electric means because the switching elements are diodes, right? Active elements are used in that, and the diodes are not normal diodes; they are specialized diodes. So the switching is fixed. So maybe this is the fixed theory behind a CPU design or a ROM design. That's why I took that example and created this. This is what a ROM is. Okay, now a small change. Think that this is a RAM, not a ROM. Random access memory, no? You can access that, right?
Yes, ma'am.
Yes,
Right? You can access it like, if at all, how you can access unless you have a key for that. This is the big shelf I'm telling. I have to access this. Now this is a RAM, not a ROM. Consider. It's just an example. Now I have to access that one. How I can open it unless I know the key? Who is the key now? How will get the key? So that is what you will study in your computer architecture. That is called memory addressing. Okay, so in your microprocessor also I'll teach. Memory will have address, and if we know the address, that acts as the key, and we can go and fetch the memory bits from there. Okay, once if at all we don't know the address, we cannot even get the pattern from that. Okay, so that is the memory designing. Memory designing means just not giving the switching elements. There's a huge story behind it. Computer architecture is completely that. I don't want to go into details, but I want to make you view this since it has this decoder and that is a combinational circuit. This ROM has come into this chapter. Otherwise, ROM would not have been in this chapter. Please try to understand that. Whole theory behind this, why I have to use ROM? Because there is a decoder there. And who is the decoder? Decoder is a combinational circuit. And I can say proudly that ROM is one of the application of a decoder, isn't it? Maybe it's very small. It is only starting point. But still it is a decoder. It has to start the ROM. Afterwards, there is a huge design. Not involved in that. Now, at present, we are not dealing to that. Is this clear today?
Ma'am, how
Yes,
do
ma'am.
we program these ROMs?
Yes, then comes the programmable logic devices. Yes, we can program this. They are called PLDs, which are called PALs, programmable array logic and programmable logic arrays. They are also there. Okay, now those are again coming into the next combinational circuits. We can program it. But Shweta, are you mentioning in a real hardcore how to program or just in the circuit board theory you wanted?
Ma'am, I was asking that in real, how these are programmed before.
In reality, how it is programmed?
Yes, ma'am. Like before manufacturing, how do they program these ROMs?
That is a real level now. I'll just tell you an example. For example, I'll go to the real coding system. You people are very happy coding in C program or your MATLAB, right? You are using MATLAB, right? Okay, today class is this much only, but now I am just deviating from that and explaining you. If you are writing in C, consider C, right? You write something code on in C, and then how the computer is understanding this. You require a compiler. Huh? You studied about compiler and interpreter? Yes?
Yes, ma'am.
Okay. Who is compiler? What is the meaning of compiler? What is the meaning of interpreter?
Compiles higher level languages into machine language.
Yes. Now this word is very easy for us. High level language to machine language. What a machine will understand? It understands only bits of ones and zeros. That means you will tell to generate a natural numbers in your language. Compiler, which is existing as a software inside the computer, that will try to go and tell that this is what the stuff that fellows has given to us. Do this program. This work in not bits of ones and zeros. Correct? So that means every word what you write on the screen will be translated to machine language. No? Machine is what? Ones and zeros only. Correct?
Yes, ma'am.
Right. How the compiler knows it? How the compiler converts it? That means compiler should have a magical instrument with that so that it can identify each of your writing and then tells. No? Otherwise, your software is not there at all. Correct? Your software is whole. I mean, heart and soul is what the compiler only. Who knows what interfacing, both high level to low level you told, or machine language. Is that correct?
Yes, ma'am.
Yes or no? Okay. Now machine language is ready to us. But this machine language has to do some task. That means it has to do some additions, it has to do subtractions and all. Where this is all happening? It is all happening where? In your ALU, no? Arithmetic and Logic Unit, right?
Yes, ma'am.
Right. Who is there inside your arithmetic and logic unit? You have lot many adders, subtractors sitting there. Already there. They are ready to do that. We will call them as registers. Okay. Who is a register? Register is nothing but a stack of or a group of cells. Okay. Group of cells who can store, who can do performance, I mean logical operations, everything. That means you have adders, subtractors, everything sitting there. Okay, so the task of your writing on the screen has gone to the level of registers, right? Not only that level, but again it has to keep intermediate memory, keep for you posted, correct? Then after, for this one, how the process is done, how the architecture is designed, right? So basically it goes from scratch level. First thing is, that is your VLSI designing will come. Okay, very large scale integrated circuit design will come. Then comes your programming part. Programming is also nothing but using electrically programming only. That means you use switches only there. You use switches only there. Like EEPROM is there, EROM is there. You heard of this one? EROM, erasable ROM, erasable programmable ROM.
Yes, ma'am.
Right. If this mesh is there, no? If I can remove all these switches and reuse this mesh to input any other thing, then it is erasable. But how you will erase? I can't take an eraser and do that. I have to use a laser technology there to throw out the switches. That means to break these switches, I have to use some what? Some optical things. To some lighting, a photodiode. If it is a photodiode, I can use some lasers to etch it out or take it out. Right, but in that process we can damage the basic source also. Who knows? Okay, so that way we cannot help. Like this mesh is integrated circuit mesh. Okay, that has to be taken. On that we have to program this one by one. Then afterwards it will come to the registers. Then it will come. I just told the reverse process and this process for you. Right? So big ocean. Big ocean. Correct. Yes or not? Electrical students?
Yes, ma'am.
Right. What happened, ma? Other class started? For that, hello? Yeah, ma. Please, somebody else other than Shweta, somebody else spoke. I'm not able to see this name. Yes, please tell. So basically what? I will start doing some machine, that round designing. Nobody will buy from this. But we can do that, no problem. Yes, what happened today? Something is wrong. Whole class is sleeping. Wait, let me call random. Harsh?
Ma'am, we have lecture after this.
Thank you, Hassan. What lecture?
Ma'am, machine.
Again, Rudra sir, no problem. I'll tell him. Okay, I'll tell him sir to wait for 5 minutes. Harsh Dikshit, is he there in the class?
Yes, ma'am.
You're there. So no questions, Harsh?
No, ma'am.
Fine.
Ma'am, I
Teja,
will go through it, then I will ask.
you go through it and I'll ask. So at least the topic is interesting. Now first time we are seeing
Yes,
a lot
ma'am.
of different manner. See, when we think of round now, we haven't think of this mesh at all. Correct. We will think something else. But seriously, this is actually an electric circuit with electronic components on that. This is what you have to understand. It's a mixture. Okay, VLSI designing is not only electronics cup of tea. It is having electrical role also in that. It's a combination. Okay. Yes or no? Teja. Who is that? There is Teja.
Yes, ma'am.
Happy understood?
Yes, ma'am, I understand.
You understood totally. Very good. Brunal? Is Brunal there?
Yes, ma'am.
Vinkesh?
Excuse me, ma'am, I could not get you.
I
Yes,
just
ma'am.
wanted to say hello to you, Brunal. That's all.
Okay, ma'am. Actually, your voice is breaking. I have a poor internet connection here.
It's okay. No problem. No problem. Happy. Rinkesh. Maruti.
Yes, ma'am.
Very good. Very good. Oh, you people are very good. That means you are in the meeting only. I was thinking you are sleeping.
No, ma'am.
Very good. Okay, now you go and enjoy your machines. Okay, big machines. Okay, tell us tomorrow I'll meet you 11 o'clock. Right?
Yes.
Okay.
Right.
Right.